Good morning. So today we are going to start our next chapter, that is unit number 4, solar energy. So in this particular chapter, we are going to cover the solar energy and its applications, particularly in thermal areas. Uh, how the radiation coming out from the solar we are using as an alternative to the conventional fuels and the conventional energy resources. Because as you know, the main reason behind using the solar radiation or the solar energy is that it is a renewable type of energy. Means continuously it will automatically generated inside in the nature. Okay, we doesn't require to give any output or anything else, and it is available in infinite manner. So because of that, we are going to use this solar radiation, which is very good energy. It is a clean energy, and we can achieve, or we can say, it is a renewable type of energy. So in this particular chapter, we are going to see the basics of the solar energy first of all, and then its applications. The application based in thermal energy storage or the related to the thermal, how to collect the thermal energy, what are the different types of the solar collectors, etc. So first of all, we are going to see the solar potential and the site selection of the solar to achieve or to get the solar energy. Then solar energy spectrum. Okay, because whenever the radiation coming out from the sun, it is that radiation will have all the wavelengths rays having all the wavelengths. Also, some form some of that radiation it is in the infrared region, some of it is in the X-ray region, and etc. So it is depends or variations are there in the solar energy which we received on the Earth surface. So that radiation spectrum we are going to see, and which spectrum or the which range of the wavelength is very useful for us to achieve or to collect the thermal energy that we are going to see. Then solar radiation geometry, particularly the radiation which is received by the Earth's surface, it is largely depends upon the relative positions of Earth and Sun. So whenever there is any tilting angle or if there is any motion, there will be a this it will going to affect the solar radiation intensity which is received by the Earth's surface. As we know, Earth is continuously rotating, right? It will continuously rotating around its own axis, and also it will revolving around the sun, and also it has been just tilted to its axis, Earth axis. So, because of that, what will happen? The solar radiation received by the Earth's surface or at a different location, it is a different one, and that geometry we have to study before going for any particular application, because it will directly affect the radiation received by that particular location. Okay, so also the radiation intensity is also depends upon the other factors like the weather and all other things. Because if we saw in cloudy, if there is any cloudy weather, in that case, radiation received by that particular location is lowest, right? If it is a clear sky, in that case, radiation is going to be very high. Okay. Also, radiation vary with respect to the weather. Okay, or we can say the with respect to the season. So that geometry and whatever the terms related to the solar radiation geometry we are going to see, and there will be some numericals based upon the angle of incidence and other type of angles. Then soil radiation data before planting planning to plant any particular solar energy or the solar PV plant or solar thermal plant, we have to study the solar radiation data. Solar radiation data which will available for that particular location all around the year, because as we know the capital cost of the solar power plant is very high, and we have to achieve or we have to absorb most of the energy which will be the available. So for that we must detail uh, study the solar radiation data, that we are going to see what are the different factors we have to consider and what are the different terms related to solar radiation data, that also we are going to see. Then the application state, or the we can see the application side of the solar energy, that is solar collector. What means of solar collectors? What are the different types of the solar collectors? These solar collectors are mostly related to the thermal part of the solar energy. So as we know, the intensity of the radiation, right? It is depends upon different factors. Also, it will vary with respect to the season or with respect to the time, etc. So we have to collect that solar radiation which is incident on the Earth surface. For that, we require different types of the solar collectors. Each collector having different advantages and disadvantages and the different characteristics. So that we are going to see. After that, we are going to see the thermal energy storage. What are the different types, or the first of all, the introduction to the thermal energy storage. What meaning or why we require this thermal energy storage in the solar energy case that we are going to see, and its types. Then the operating and principles of photovoltaic cell concept, as we already know, most of the electrical energy which is generated through the solar radiation, it is in the it is used or it is generated by using or with the help of PV cells, right? Photovoltaic cells. So, what are the operating principles and the characteristics of that photovoltaic cell? How it is working, and what are the different materials? What are the different terms related to PV cells that we are going to see? And it will be only a descriptive treatment related to the photovoltaic cells or the PV cells, we can say. How to design the system by using the PV cells, and what are the how to track the maximum power which will obtained from the PV cell. So these are the factors or these are the points we are going to cover in this particular chapter. It will be just an introductory part or the basics of the solar energy. Based upon that, there are the applications, and we can say or we can study the applications also, because the solar energy will be received by the Earth surface. We can use that energy in two ways. First of all, by using the thermal to convert that radiation into the thermal energy, and then we are going to use, or rather, we can directly convert that radiation into the electricity by using the PV cells. So these are the two main, we can say, the branch of the solar energy, or we can say the different uh, two factors of the uh, methods to achieve the solar energy. So first of all, the solar potential. As we know, why we require to use the solar energy, or why we are mostly concerning or we are concentrating on the solar energy in these days. So for that, you must know the some background of the energy resources. What are the different types of the energy resources are there, and how we achieve the general electricity of the from these particular resources. So we know most of the electrical energy, most of the electrical energy will be or the solar energy. Just a second. So the solar energy or the we know the conventional energy resources. Those are the non-renewable types, or those are the we can say the so those are the non-renewable type of resources, and those particular resources also cause the pollution problem, global warming problem, etc. Okay, there will be some cost which is related to achieve those non-conventional, conventional type of the energy resources, like the petroleum products and the nuclear energy, coal. We are using in the thermal power plant. So these are the some type of the conventional type of energy resources, and the the main disadvantage of this particular energy is that uh, we require some cost, or cost is related to that particular energy. So to avoid that, we can use the solar energy, which or the solar radiation, which are available freely in the atmosphere or in the nature. So whatever the solar radiation coming out from the sun, that radiation we can use to create or to generate the power or the electricity. Okay, so solar energy, it is just an energy which is coming from the sun, directly coming from the sun. It may be in the light form, it may be in heat form. Generally, it is in the radiation form. Now, the examples are many examples are there. You can see how the solar energy is trapped, or how it will convert into the thermal energy. If you park one car into the in open atmosphere where the solar radiation are incident on this car. After some time, the surface of that car will heat up. Okay, so means what, the radiation which is coming out from the sun, it will travel all across the vacuum. Okay, when it is going to incident on the surface of the car or the roof of the car, it will going to convert from radiation to the thermal energy or the into the heat. Okay, so that will make the car surface hot or the which is attain the higher temperature. Similarly, the solar calculator, the plant also uses the solar energy. Solar PV panels, we know those are using the solar energy. So these are some examples of the solar energy. Now, whatever the solar radiation, the amount or intensity of the solar radiation which is reaching the Earth's surface depends on the geometric relationship of the Earth with respect to the sun. Now, this radiation coming out from the sun, it is going to affect or affected by the geometrical relationship of Earth and sun. Okay, so basically, if we know how sun is working, first of all, how it will generating this much of radiation. So, as we know, this is the sun. Sun is not an, just an gas balloon, we can say. Okay, it is contain all the gas in it in the terms of hydrogen. Now this hydrogen will combine together, two more, atoms of the hydrogen will combine together and it will generate the helium. This is known as a nuclear fusion reaction. And after this nuclear fusion reaction, tremendous amount of heat will be generated. Now, this tremendous amount of heat, which is generated because of the nuclear fusion reaction, it will travel or it will be converted. Some part of that heat will be converted, or the some part of that energy will be, has been converted into the radiation, and that radiation will travel all across from the vacuum. Okay, all across from the vacuum, and some part of that radiation will incident on the surface, Earth's surface. The sun will be radiate that energy in all the directions. Okay, so most of this radiation will does not going to heat the Earth's surface. Most of that radiation will be goes on in the outer space. Okay, only some part of that radiation will incident on the Earth's surface, and that radiation or that radiation energy we are going to use to generate the electricity. Okay, now for that you must know how there is a geometrical relationship between the sun and earth. Okay, as we know, sun is if you saw the geometry related to the sun and earth, the earth is revolving or the it will rotating around the sun. Okay, in the fixed path or in the fixed orbit, and also it will revolving around its own axis. At the same time, earth is just tilted from its axis by 23.45 angle. Okay, 23.45 degree angle. And because of that, we will observe some different types of the seasons. Okay, so these are the relations or these are the geometrical relations between sun and earth. As we know, the earth will orbit the sun in elliptical path or the elliptical orbit. It will so because of this elliptical orbit, you saw there are 2 points where earth is very much near to the sun, and there are 2 points where earth is very much uh, earth and sun having the largest distance. Okay, and that path you can see on the so when earth the distance between earth and sun is maximum, those particular points are called as the perihelions or helions. Okay, and when earth and sun having minimum distance in between, that particular points are called as the equinox. Okay, now the equinox, what are the difference and equinox and all those solstices are the which is depends upon the directly related to the distance between sun and the earth, and also the relative geometry or the relative position of the earth with respect to the sun. Now, these solstices, as we know, during the solstice, what will happen? The distance between earth and sun is maximum, so the radiation which is coming from the sun to the earth or incident on the earth surface will be the minimum. Okay, in that case. So you will observe during this solstice days, which is happen in the June and which is happen another time in this December. So you can see at that particular time in northern hemisphere, during the June there is the summer. Okay, where that particular position is much more the northern hemisphere is much more uh, we can say the near to the sun, and during the winter solstice in the northern hemisphere, in that case the northern hemisphere is much more away from the sun. Okay, so that is those 2 days are called as the solstice. Then equinox means those are the days when the what we can say the duration of the day and duration of the night is equal. Okay, means there is a 12 hours night and 12 hours days will be there. Day will be there. So this equinox will happen during the September and during the March. Okay, so this is the difference between equinox and solstice. In the solstice means what? There will be a the day must be having very high time, or we can say the duration of the day is maximum in the case of solstice, and in during the equinox, the day and night, the duration of day and night will be the equal. Okay, so that variation or that variation or the variation in the geometry, or we can say the position with respect to the sun, or the related between the sun and earth, that will cause the variation of radiation which is received by the earth surface. Also, the distance between the sun and earth, that is known as the one astronomical unit, which is equal to 14.9 into 10 raised to 7 kilometers. So this is one point or the concept you must know. Okay, now that you can see here solstice, meaning of the solstice. So it is an astronomical event that occurs twice each year as the sun reaches its highest or lowest exertions related to the celestial equator on the celestial sphere. Or as a result, because of this solstice, a day of solstice, the sun happens to have reached its highest or lowest annual altitude in the sky above the origin at local solar noon. Means during the solstice, what will happen? The night will having the maximum duration, or day will having maximum solution. It is duration. It is totally depends upon in which hemisphere you are situated. Okay, and during the equinox, equinox means what? It is also occurs twice in the year when the tilt of Earth's axis is inclined neither away from the sun or nor toward the sun. Okay, means the center of the sun being at the same plane as the Earth equator, and during this equinox, the duration of night and duration of day is equal. Means 12 hours day will be there and 12 hours night will be there. Okay, so this variation in the relative position between the sun and earth will cause the variation in the radiation which is received by the earth surface. So again, the radiation coming out from the sun, it will reaches the earth surface. Before that, it will reaches to the earth atmosphere. As we know, earth is having the atmosphere. Now when this radiation, solar radiation, incident on the outer surface of the atmosphere, some part of that radiation will be reflected. Okay, some part of that radiation will be reflected back, because some gases are the reflective in nature. So some part of that radiation will reflected back into the outer surface. Then remaining radiation will enters into the earth atmosphere and going to hit the earth surface. Okay, now this radiation which is actually hitting the earth surface, that radiation we are going to use to generate the power, or generate the going to use for many other applications like the thermal application and all other things. Now this radiation, solar radiation, which is hitting the earth, it is also cause other phenomena on the earth also. Okay, like the hydrological cycle, like evaporation of the water, that water going to be become the clouds, and after some times it will just precipitated in the form of rain. Okay, that will indirectly create or the create the hydroelectricity, or we can say the hydraulic power. Okay, the same radiation which is also causes the wind, or the wind and wave energy. How that radiation is going to be incident on the air, which will heat up the air, and because of the heating of the air, density difference will happen. between two locations, and because of that difference, density difference, convection will be happen, or means that wind will be traveling from one location to the another location. Now, so this is because of the solar radiation which is incident on the Earth surface, right? Similarly, the because of the relationship between the Earth gravity and the Moon gravity, there are ocean tides are there. So this sun radiation does not just related to the radiation energy of only those solar thermal and photovoltaic applications. It will also contribute the other important phenomena on the Earth, that is hydrological circuit, cycle, convection, current, and other things. Okay, so the radiation in this particular chapter, we are going to focus on the actual applications of the solar radiation, the thermal applications, and the PV applications. Okay, so before we moving towards, we are going to see the some basic concepts related to the sun and the solar energy or the solar radiation with respect to the Earth. The first point you must know, that is the solar constant. Now, what is meant by solar constant? Solar constant is the amount of incoming solar radiation which is hitting the Earth's surface or per unit area, that is known, that particular intensity or that particular amount of energy is known as the solar constant. Means if we consider 1 meter square of area on Earth's surface, okay, 1 meter means it's having the sides of having 1 meter, and this particular square, how much solar radiation which is incident on this particular area, it is known as a solar constant. Okay, now we can calculate that one at the entry point to the atmosphere or on the Earth surface. Generally, we are considering that intensity is all as around the 1350 watts per meter square. Means if we uh, if we saw one particular 1 meter square of area on Earth surface, it will generally receive the 1350 watt of energy per day. Okay, sorry, per second. Okay, so this much of energy will be received by that particular area. Okay, so this is known as a solar constant. So we can define that one. It is the measure of flux density, or it is the amount of incoming solar electromagnetic radiation per unit area that would be incident on the plane perpendicular to the rays at a distance of 1 astronomical unit. Means it is the distance between the sun and Earth. Okay, now in that case, that particular surface must be perpendicular to that solar radiation. Okay, because as we already studied this in radiation part, in heat transfer, uh, whenever this particular surface is perpendicular to the solar radiation, the intensity of that solar radiation will be maximum. So because of that, to whenever we're going to measure the solar constant, maximum radiation will be incident, or the intensity of the radiation will be maximum if that that surface will be just and perpendicular to the solar radiation. That is known as the solar constant, and the value of solar constant is 1350 watt per meter square. We already say. Now this solar constant is going to be vary with respect to the location, with respect to the weather condition, etc. But roughly we are considering that solar constant is all around 1362 or 65 watt per meter square. Okay, it will varying with respect to the weather condition, with respect to the location, etc. Okay, it will going to be fluctuates. Now, next, that variation. Okay, now this variation, it is also depends upon the days or the seasons, right? Because with respect to the seasons, so as the day passes, the relative position of the sun and earth is going to be vary. Okay, it will going to be changes. It's going to be changes. So because of that, the solar radiation or the solar constant is also going to be changed. Now that solar constant or the intensity of the solar radiation incident on the Earth surface, we can calculate by using this particular formula. Okay, so you can see the intensity of the solar radiation on that particular day is equal to solar constant, that is the standard value, that is 1353 or 1365 watt per meter square, into 1 plus 0.033 cos 360 n divided by 365. Okay, and this n means it is the day of the year. Generally, year having one particular year is having 365 days. If it is a leap year, it will consist 366 days. Okay, so from that, the number of days from 1st January, that is known as the year. So based by using this particular formula, you can calculate the actual solar constant on that particular day. Here we are not considering consider any effect because of the weather and other local climate. Okay, we just considering there is a clear sky, and based upon that we can calculate the solar constant, which is situated on that particular surface is situated on the equator. Okay, so by using that we can calculate the solar constant. This particular formula is important. Now, the sun radiation, as we know, the radiation, it doesn't require any type of medium to travel, right? So it will generated at the solar sun's surface, and it will travel from the sun to the earth through the vacuum. Now, when that radiation will going to touch or going to enter into the atmosphere, some part of that radiation will reflected back because of the cloud and the properties of the atmospheric gases. Okay, so some part will going to be reflected back into the outer space. Now remaining part will going to be enters into the earth atmosphere. Now the some part of that solar radiation is also going to be absorbed by the water vapor and other gases which are present into the atmosphere, right? Means some part of that solar radiation, we already know that ozone layer which is present in this particular atmosphere, it will absorb the ultraviolet rays. Means it is one type of radiation. Okay, it is a part of the radiation. So some part of that radiation will be absorbed by the ozone layer. Okay, so intensity of the radiation is going to be decreases. Okay, now when that radiation will hit the earth's surface, in that case what will happen, some part of that radiation which is hitting the earth's surface, some part will get absorbed by the earth. Okay, some part will get reflected back to the outer atmosphere or to the atmosphere. Okay, now this reflected radiation may be absorbed by the other gases, or it may be directly reflected to the outer space, whatever will happen. Okay, now whatever the radiation which is actually incident on the earth surface, that much of intensity or that much of radiation energy we have to use. Okay, now these particular radiation energy, it has been used to generate the electricity on all other solar applications. Now, because of the heating of the Earth's surface, that particular that particular object or the Earth is also having some characteristics. Okay, it will also emit some form of radiation. Now, whatever the radiation coming out from the sun, it is the a very small wave radiation. Okay, or it is a very small wave radiation we can say, or it's having very small wavelength. Okay, so because of that, it will directly enters into the atmosphere. Most of the radiation will falls on the Earth's surface. Now, this fall radiation will heat up the Earth, and that heat Earth surface also start radiating some radiation. Okay, and that radiation which is in the form of long wave radiation, right? Like in the terms of radio waves, or the in the forms of infrared waves, etc. Now that reflected or the emitted radiation by the earth, it is also going to be absorbed by the earth's atmosphere gases, or some radiation will directly leave the earth's surface. So this is the phenomena. These all phenomena are happening inside the earth's atmosphere, and that will going to be affect the amount of radiation which is received by the earth's surface. So whenever we going to design any particular plant, or any particular system which is running on the solar radiation, we have to consider all those factors. Okay, you must know all those factors. These are the basic things. Now, generally, whatever the radiation coming or the received by the Earth surface, it has been uh, classified into the three main types of the radiation. First one, that is the direct radiation. Now, direct radiation, consider there is one surface which is, we have to study how much solar radiation received by this particular surface. So, direct radiation means what? The radiation directly coming from the sun surface to that particular surface, okay, or to the particular collector. That is known as the direct radiation. There will be no any reflection, or there will be no any refraction, or any particular other phenomena are there. Okay, so the direct radiation or the radiation coming directly from the sun surface to the that particular collector is known as the direct radiation. Now, some radiation from this solar radiation will going to be impact or going to incident on the cloud or other gases which are present in the atmosphere, and it will get reflected from that particular object. Now, whatever the radiation or the energy which is received by that reflected radiation from the other object, it is known as the diffused radiation. Okay, it is known as the diffused radiation. Okay, so generally these two are most important points or the most important concepts in the radiation: direct radiation and diffused radiation. Okay, the intensity of direct radiation is much more higher than the diffused radiation whenever we compare the intensity. Now, whenever we add these two radiation, it is known as a global radiation, or we also called as a insolation. Okay, it is also called as a insolation. This reflected radiation is also considered as a diffused radiation. Okay, so these three concepts are most important. First one, direct radiation; second one, diffused radiation; and third one is known as the global radiation, or sometimes we also called it as irradiation. Okay, irradiation, the total amount of radiation received by the particular surface. Okay, it will contain the direct radiation coming out from the sun and the diffuse radiation. Okay, so irradiation or global radiation or insolation, it is known as a, or it is the just summation of beam radiation and diffuse radiation. Okay, now this radiation is useful for us to achieve or to convert that used to convert the solar convert to into the electricity or other thermal storage. Okay, now, now why we require to generate the electricity from the solar power? As we know, it is a renewable type of energy. Also, there is no any pollution because of this particular energy, and it is freely available. Okay, it is freely available, which will which is very much most important advantage in this particular the particular type of energy. Okay, some disadvantages are also there. Means it is depends the intensity of solar radiation or availability of solar radiation. It is depends with respect to the location. It is depends on the weather. It is depends on other local aspects or the other local phenomena. Okay, but the most important advantage is that it is a renewable type of energy. It is freely available in the nature, and also it does not contain or generate any type of pollution. That is the most important factors or the characteristics which are very useful. That's why we are mostly concentrating on the solar power. As we know, because of the use of conventional fuels, there are much big problems we are facing now, like the global warming and then the other air pollution, soil pollution, and the water pollution, etc. So to avoid that, we are mostly concentrating on the solar power. Now, the one of the benefits for India is that all over the air, the Indian part of the Earth will receive the uh, sufficient amount of radiation. Okay, because we are nearly situated near to the equator, so these particular Indian plate will receive the average, all an average, sufficient amount of solar radiation, which can be converted into the useful energy, right? So you can see on the right and left hand side, you will see the direct or normal irradiation. Okay, direct type of radiation. it will give you the idea. You will see the most of the part of Indian plateau will receive the sufficient amount of radiation. Okay, if you saw the on an average, it will receive 1826 kilowatt hours per meter square of energy. Okay, this kilowatt hour means 1 unit, right? So it will that particular 1 meter square of area will receive 1800 or we can say 1400 units of electricity electricity or the energy per meter square. Okay, so that is sufficient for us, right? Similarly, if you saw the photovoltaic power potential, you can see right hand side, you will see the one counter map of the Indian plateau. You will see it will having photovoltaic power potential, how much potential is there. Here also you can see most part of that India will receive sufficient amount of radiation, or it is having sufficient amount of PV power potential. Okay, if you saw here, it is around 1461 units per kilowatt of PV cell. Okay, so because of that, we in mostly in India we are concentrating on the solar energy. We will receive the sufficient amount of solar radiation all over the year, and also it is an renewable type of energy resource. Okay, so that's why we are going to focus on the solar energy. So the introduction related to the solar energy. In the next lecture, we are going to see the solar potential of the India in India. What are the current status of the solar energy in India, and the next point that will be based upon the solar radiation geometry, or we can say the different terms related to the solar energy, which are very useful or which are very important. Okay, so that's it.